Hello, everybody. This is the second of the two uh, videos I'll be putting out today, and this is to go over the homework that I want you to do. The last one that will be on hashing. Now, you've already written or are writing two programs, 23 and 24. Each of them is a program to set up a table, and each of them reads the same material, but it sets up the table differently. One has the elements of the table pointing to linked list, and the other has the elements of the table pointing to a single node. Both start out as null. What I want to do is try to find out a comparison between the two. What should we count? Well, I decided to count the number of times we have to read something, either read an element of the table or read a node. Now, when I read a node, I didn't make it separate, reading the name and reading the meaning. I just read the node. I figured it was just once. So, what you're going to do is you're going to take your two programs and you're going to create the tables in those programs. I suggest that both of them be the same size. I use 2000 as the size. It turned out after I wrote the program, I realized I only need one hash, since it's the same hash function for both of them. But I wrote it with two hash functions. I don't feel like changing it. And also, by doing it this way, I can vary the size of one table without varying the size of the other table. Now, there's another file out there besides the one that is for homework 23, which is also used in homework 24. I call it homework 25 full. The reason I put the FULL there was because the first one didn't contain anything that wasn't in the table. So I added things that weren't in the table, and I just gave it a fuller name, shall we say. There are 600 lines in the table, I believe. Each of them is a name. And what you're after is to print out the name and what the meaning of the name is. The in meaning that you read from the file is what each name means. So what you're going to have to do is combine your two programs somehow. So you read in the data, you can read it in once, and then put it, and then add it to the table. What I did down here in the starter program is basically the main line reads the 23 data, breaks it into pieces. I did that for you. Adds to the chain table, adds to the linear table, and it calls the hasher chain and the hasher linear. So this part here sets up the tables. Now you go to the new data file, and again you read line by line. And all that's on there is a name, so you don't have to break it up into pieces. What you're going to do is take that name, which I call valin, you're going to hash it and try to find it in the chain table. You're going to hash it and try to find it in the linear table. Those will be outputting the answers. When you finish all of them, you're going to tell me how many accesses each of them took. The variables count chain and count linear are global variables that come before the main line and before all the functions. That way they can be used in any function. You have to take the pieces that you have and put them in these places. And then you have to write two new programs. Locate in the chain and locate in the linear. And in each case, If you find it, you print out something. If you don't find it, you print out not found. Now here's the end of my input. My input was like 1,200 lines or more. You don't want to see that. Trevor means great house. I don't know why I said Trevor not found. In fact, I think I'm going to erase that because I don't know what happened there. See, chai not found, chai not found. Morgan, Gill not found. It looks like some of them are coming out differently, and I don't know exactly why. But I'm not going to worry about it. I think I might have a slight glitch in my program. If I do, I'll put it out for you. How do you do it? Well, it's not as hard as it sounds. First of all, what's an access? I'm looking at an access as getting the element in a table. So if you have something like if table H equals null, that's getting the element in the table. And I'm looking at anytime you touch a node by doing temp point to, you're bringing up that node. That's an access. Now, if the next line is temp point to in meaning, don't count it twice, just count it once. So in the chain, those are the things you count. In the linear, it's the same, except here it's a little easier. Oh boy. I didn't realize I was doing that, but that's not going to hurt anything. Up here, when you're counting the linear, what you count the access to the table twice, because you're accessing the table and you're accessing the pointer at the table. So instead of doing it in two separate places, do it once, just add two. Now here's the hints. In the chain case, hash the name, go to that place in the table, and search the linked list. So this is a search of a linked list. In the linear case, hash the in name, go to the table. If the place that you're at is null, then it's not in the table. If it has something in it, if it's what you're looking for, then you found it. If it's not what you're looking for, go to the next place in the table, and the next place in the table, and the next place, until you find what you're looking for, or you find an empty location. Because remember, if it's there, it was put in either at the hash or the next one, or the next one, or the next one. So if you hit a null, it wasn't put in. So that's it for now. I'll take a look at my program to see if I did something I shouldn't have done, and I will put these out very shortly.